Hello and welcome back to this beginner series for programming in Rust. Now, in the last video, we learned how to group related data together using structs, where every field is present at the same time. In this video, we're going to model the opposite situation, where a value is exactly one of several possibilities and never more than one of them at once. And the tool that we're going to use for this is the enum. So think of a traffic light. At any given moment, it's red, amber, or green, but it's never two of those colors at the same time. An enum lets us describe exactly that kind of either-or value, and Rust then gives us a precise compiler-checked way to respond to each possibility, which is called pattern matching. This pairing of enums and match is one of the features that people enjoy most about Rust, and we're going to lean on it in our next few videos in this series. So we're going to start by defining enums, including different variants that carry their own data. We'll then meet option again. We touched on option a little bit at the start of this series, and essentially it represents, or it's how Rust represents, a value that might be missing, and which takes the place of the null, which you may be familiar with if you've programmed in other languages. After that, we're going to handle every possible case using match, and finally we'll look at two lighter weight tools, the if-let and let-else, for a common situation where you only care about one case. Okay, so let's start off by creating a new program. So I'm going to open up the terminal, go cargo new enum pattern match. It's going to go ahead and create my new program. I'm going to cd into that and then clear. Open up the file explorer and open up the Rust file that it generated as part of cargo new. Awesome. So let's start by defining an enum whose variants can each carry a different kind of data. And we can do that like so. Okay, so this enum is called event, and it models different things that might happen in a graphical program. Notice how each of the four variants has a different shape. So the close variant carries no data at all. It's just close, so it's going to be a close event that doesn't need to contain any extra information. The resize variant carries two named fields. So we've got width and height. So it kind of looks like a very small struct. The log variant carries a single string, which is essentially going to hold the message that was recorded. And then the recolor variant carries three unnamed numbers, which is going to stand for red, green, and blue parts of a color. The crucial idea is that this single event value is always exactly one of these four shapes, and the compiler always knows which one it is holding. And that's what makes an enum different from a struct. So a struct will hold all of its fields at the same time, whereas an enum holds exactly one of its variants at a time. Now, because we've added the derive line at the top, derive debug line at the top, we can build a few events and print them to see the different shapes in action. So let me get some better real estate going, remove this line, and let's see this in action in our main function. Okay, got my terminal up, and let's go cargo run. Let me have a look. I forgot to put this in there. Nice happy accident. I'll just clear. Run that again. And here we go. So each line shows how we've constructed one variant. So close, like I mentioned before, needs nothing at all. The resize variant takes the fields inside curly braces, whereas log takes its string inside parentheses, and the recolor takes three numbers inside the parentheses. So just like structs, enums can also have methods like an implicit block. So we touched on that in our video when we covered structs. And those methods almost always begin by matching on self to see which variant that they were given. That word match is the other half of today's topic, so let's take a look at that properly now. So many languages have a special value called null, which essentially means that there's nothing here. That may sound convenient, but it can be a source for a lot of bug crashes and a lot of pain for developers, because it's far too easy to forget that a value might be null, and then we try and use it as if something was really there. Rust takes a different path. It doesn't have null at all. Instead, the standard library gives us an enum called option, which makes the possibility of an absence visible in the type itself. Now, we did touch on option earlier in the series, but just to recap, an option is either something or some, which wraps around a real value, or none, meaning that there's nothing there. Let's write something out in our main function just to see this in action. Let's go ahead and run this. So I'll get back into my terminal that I was using. Cargo run. And let's look at the bottom two bits of output there. So an option is either something wrapping around a real value. So in this example, it's an integer, or nothing, meaning that there's nothing there. Now, if I just go back into the code, scroll up. To describe a placeholder, we usually have something like a capital T, which simply means that the option works for any type that you like, whether that's an option of an integer, as we're implementing here, an option of a string, or anything else. And here we've just made two of them. So this is something and this is nothing, and we've printed it out down here. Now, because the possibility of absence is now baked into the type, the compiler won't actually let you reach the 42 inside maybe ID without first dealing with the chance that it might be nothing. So you can't forget the empty case, because this type of, where is it now, of option, I'll just put the terminal down a little bit, won't allow it. The way you actually check which one you have is for our next topic, match. Now, a match expression compares a value against a series of patterns from top to bottom, and then it runs the body of the first pattern that fits. So let's make a small function that doubles the number inside an option if there is one. So I'll just get rid of the terminal, and let's write the following. Let's run that now. Open up my terminal, and we'll see what happens. Okay, so we've got these two values here, sum 10 and none. But let's look closely at the two arms. So the none arm, this one here, is fairly straightforward. If there's no number, there's nothing to double, so we hand back none. The sum arm, something is actually happening here. So this pattern sum n does two things at once. First, it checks the value, checks if the value is actually a sum, and it pulls the number out of it and then binds it to our parameter of n. So then we can use it on the right-hand side. This is called binding, and it's a big part of why match is so much more powerful than a simple switch statement that you'll see in other programming languages. So if I go ahead and just pull back up the terminal again, we can see that that's done what we've wanted it to do. So it's doubled the number once we've provided something here. So we're passing number 5, wrapping it around sum. So we're getting something of 10 back. And when we pass through none, we get none back. So that's pretty neat. Now there is one more rule that matters quite a lot. A match has to be exhaustive, which essentially means you have to cover every possible case. And the way we can prove this is just by getting rid of that none and then trying to run our program again. Okay, so we've got this error here, and not, here we go. So this pattern none is not covered. So the compiler has actually stopped us here and names exactly the case that we forgot. This can feel a little strict at first, but it's actually a really awesome safety feature from Rust because it makes it impossible to silently forget a case and accidentally ship bugs. So when you don't care about the remaining possibilities, all you need to do is include a catch-all case, which is what that none arm is doing, because it matches anything that you haven't already handled. Sometimes writing out a full match is more than what we need because we only really care about one of the cases. For the situations like this, Rust gives us a couple of lighter tools to use, and the first is if let, which essentially runs a block only when a value matches a single pattern and quietly ignores everything else. Okay, let's open our terminal. Make sure I'm in the right directory, and then cargo run. Okay, so you can actually read this line. I'll open up the code again. That if user quota matches pattern sum, bind the inner value, so inner value of limit, and run the block. Otherwise, do nothing. So essentially, this is exactly a match with a single arm, but it's shorter and easier to read when that's all you want to do. The second tool that we have is let else, which is a mirror image of if let. So essentially, we bind the value, if it binds the value in the normal case, and if the pattern doesn't match, it runs an else block that it must diverge, meaning it has to return, break, or panic. Let's see that in action. Okay, let's open up our terminal again. And we'll run that. I'm missing a curly brace. Line 51. There we go, another happy little accident. Hopefully that was the only mistake. And there we go. All right. So we call greet, open up the code again, with sum, and then I'm passing my name through. And that let binds the inner string to name and then carries on with the greeting. When we call it with none, the else block runs, and it's essentially saying no name given. So when we call the greet function and pass none through it, what gets printed out rather than none is no name given. The big win here is that after the let line, the name is guaranteed to exist, so the rest of the function can use it directly. This helps keep your main path flat and readable instead of pushing the real work deeper and deeper to inside the nested matches, which I think is pretty cool. Okay, so before we move on, let's recap what we've learned in this lesson. So an enum is a value with several shapes. So essentially it lets one type be exactly one of a fixed set of variants, and each variant can carry its own data. This is perfect when we need to use something that is one of these options or represent something that could be one of these options. Option replaces null. So instead of a value that might secretly be nothing, Rust is really powerful in that it makes that absence more visible. Sum holds a value where none means that there is nothing. And this is powerful because you can't forget to handle the empty case because the type forces you to do it. Match forces you to handle every case. So when you match on an enum, the compiler will check that you've covered every variant. Forget one and your Rust program won't compile, which turns a whole class of bugs into an error that you can see immediately before you ship it out to customers or your users. And finally, the if let and let else are more lightweight tools that we can use instead of match. So when you only care about one pattern, the if let handles it in a couple of lines, while the let else pulls in the value or it bails out early, keeping your main path flat and readable. That wraps it up for this video. In the next video, we're going to cover modules, the standard collections, and also error handling, which are all the pieces or the final pieces we need before we build our next project. If you like this video, give it a like. If you're enjoying the series so far and you don't want to miss out on other videos, on this series of learning how to program in Rust or other videos such as Azure or anything I decide to publish in the future, make sure you subscribe. If you have questions, please pop them in the comment section below. Links to all the resources are in the description as well. Thank you so much for joining, and I'll see you in the next one.